Greetings everyone, this is Mr. Mull, and today I'm doing a podcast on how to find the limiting reactant for a reaction, and then also how to solve for excess of the reactant that was not used. So we're going to start with an example of s'mores. So I have my recipe for s'mores. I love making these things, and I go in my cupboard and I find out that I have 18 chocolate bars, 24 graham crackers, and 80 marshmallows. The problem with all of this bunch of stuff is that I may actually not be able to make all the s'mores that each one of these ingredients would tell me I could make. For example, if I have 18 chocolate bars and I want to figure out how many s'mores I could make, I look at my recipe. Okay, I could make one s'more for every, look at my chocolate bars, half a chocolate bar. So when I figure out, okay, how many could I actually make, I could take 1 divided by a half. I'm going to have enough chocolate to make 36 s'mores. And so that's assuming that I have unlimited every other ingredient. So I go and look at the same thing. Okay, well, if I had just 24 graham crackers, how many s'mores should I be able to make with all of those graham crackers? So one s'more is going to be 1 graham cracker. So with my graham crackers, I should be able to make 24 s'mores. Well, I look at my marshmallows and I say, okay, well, if I had all my marshmallows and I could use them all to make s'mores, I could make 1 s'more for every 2 marshmallows. So I can really make 40 s'mores. So the question becomes, can I really make all of these numbers of s'mores? And the obvious answer is no, I cannot, because as soon as my graham crackers, as soon as I've made 24 s'mores, my graham crackers have run out, and I'm out of graham crackers. I can't make any more. So I really can only make 24 s'mores. How many can we actually make? Because I run out of graham crackers. Okay, 24 s'mores. We call this amount of product that we can make in a reaction our theoretical yield. It's how much we should be able to make given I didn't break a graham cracker in half and have it fall on the ground, and so I can't actually make, I could only make 23 s'mores. It's assuming all those graham crackers were reacted to make s'mores in a perfect ideal situation. We call it a theoretical yield. If for some reason I dropped a graham cracker and one broke and I only made 23 s'mores, that would be called a actual yield. Okay, given the experimental design, we worked through the problem, I could only make 23, I should have been able to make 24. We would call that our actual yield. Theoretical yield always comes from this idea of something running out. It comes from this thing here. So which ingredient runs out? That was our graham crackers. Okay. Our graham crackers are going to run out. So what that means is this idea here is called our limiting reactant. Okay, that's what we call that ingredient that runs out first. And then the last question says, how many marshmallows are left over? Okay, so to find our leftover, our number of marshmallows left over, we need to figure out how much did we use. Okay? So to find our leftover marshmallows, I'm going to figure out how much I used. And to figure out how much I used, I'm going to look at what ran out first. So graham crackers was the one that was determining how many s'mores I could make. So when I take my 24 graham crackers and I say, okay, how many marshmallows do I need? Well, I need 2 marshmallows for every one of those graham crackers. And so I take my limiting reactant, I convert it to the other reactant, okay, other reactant, and that's going to tell me how much I used. Okay, how much did I use up? So I multiply that and I figured out that I used up 48 marshmallows. Okay, I just take my limiting reactant and figure out how much I used up. So I used 48. How many do I have left over? Well, that's simple. I started with 80 in my bag. I used 48. I'm left over with 32 marshmallows. We call this leftover our excess reactant. Excess reactant. Okay, so let's take this idea to chemistry. I spelled graham cracker wrong. Okay, so how do I find limiting reactant? Method 1, I'm going to show you 2 different ways to do this. Method 1, we use the mole-to-mole ratio, and you look at what's called a have-to-need relationship, and I'll show you an example in a second. Method 2, we're going to kind of a little bit longer process, but it works like we just did. We take all of our reactants given in the problem, and we convert them all to some product. And then when we look at the product, we looked at the lowest amount that we could actually make. In the case before, it was 24 graham crackers. And that's going to tell us which reactant ran out first. So I said I could make 24 s'mores. I converted them all to s'mores. And the one that showed me I could only make 24 was the graham cracker, so that was my limiting reactant. So we're going to do both of these methods, method 1 and 2. Okay, so the first method is we're going to look at what's called a have-to-need relationship. So I have 5.0 moles of CuCl2. Okay, that's how much I have right now. So my question is, if all of this reacts, if I have a full cupboard of other ingredients, how much of this other stuff do I need to go with it? Okay. So I'm going to go ahead and take all of that, and I'm going to say, okay, if all 5 moles of those react, look at my recipe. I need 2 moles of Fe for every 3 moles of CuCl2. So when I take 5 times 2 divided by 3, I'm going to get 3.3 moles of Fe. What that represents is how much Fe needs to be present to use up all this stuff here. So if I want to use up all of this reactant, all the ingredients, the other ingredients I need are Fe, because those both are involved in this reaction. So this is how much I needed to use up my limiting reactant. So that's how much I need. So I'm going to look at what I actually have here. I have 7.5. Now I needed 3.3. I definitely have enough. In fact, I have over double what I need. So because I have more than I need, that reactant is automatically in excess. We have more than we need. And so if we have more than we need of this, that means that all 5 of this moles can react until it runs out, and we call that our limiting reactant. Okay? I want to take a look at this other example. Let's say we have the same problem. I have 5 moles. How much do I need? Well, I need 3.3. So I look at my pile, and I only have 1 mole of Fe left. So I do not have what I need. Okay? Because I don't have what I need, that means that this guy here is going to run out way before I ever get through 5 moles of this. So if I don't have what I need, then you know that one is going to be the limiting reactant, and the other one is going to have some excess left over. And so that's how I know. Okay, this is one way to find the limiting reactant. Okay, is look at the have-to-need situation and figure out, do I have enough? If I have more than I need, it's going to be in excess. If I don't have enough, it's going to run out first. Another way to do this is a secondary method. And this takes a little bit longer, but it still always works, is we take both reactants, and we're going to convert them to the same product. Now it doesn't matter which one, I'm just going to choose copper. So we're going to take both of our reactants, and we're going to convert them to the same exact product. So I'm going to just choose copper. I'm going to say I want to make 3 moles of copper. Okay, looking at my recipe, for every 3 moles of copper I make, it takes me 3 moles of CuCl2. I'm going to do the same thing with my other reactant. We're going to say, okay, in a perfect world, if all my iron was able to react, how much product can I make? Think back to the s'more idea. How many s'mores can I make? So I can make 3 moles of Cu for every 2 moles of Fe. So I'm going to go ahead and punch this out. Notice my units are canceling here. The first example is going to be simple enough. I could make 5 moles of copper. The second example is going to yield me 11.25 moles of copper. Here's the problem. Once I make 5 moles of copper, my copper chloride that it took me to make it runs out. And so if I want to make any more than 5 moles of copper, I'm not going to have any more of this ingredient left over. So that means this guy must be my limiting reactant. the lowest amount that we could make is going to tell us what our limiter was. I'm actually not going to be able to ever make 11.25, so that must mean that this other guy is going to be my excess. Okay. So that's another way we can find our limiting reactant. Convert to one product, figure out which one would make the less, and it would give us the one that ran out first. Okay. The last thing I want to do is, once we determine our limiting reactant here, okay, we already said it was this one, we can find the excess, or the leftovers. So in order to do this, we're just going to take the total amount of excess reactant. So right now I have my total amount. This is my limiter. This is my excess. So my total amount excess was 7.5 moles. Okay, that's given in the problem. Minus the amount used by limiting reactant. Okay, so I go back to my limiting reactant. It was 5.0 moles of CuCl2. Now what I need to do is I need to figure out how much was used by my limiting reactant. How much of this other reactant was used? Just look at the units. I have 7.5 moles of Fe. I'm going to need moles of Fe to subtract from there, okay, to figure out how much excess I have left over. So I need to convert and churn over how much of this stuff, iron, was used from that 5 moles. So I'm going to use my recipe. Okay, so if my recipe says I can make 2 moles of Fe for every 3 moles of CuCl2 that I use. So when I take that relationship, 5 times 2 divided by 3, I'm going to go ahead and get that I have 3.33, and we already did this in a previous problem, moles of Fe was used up. That's how much I used up. So if that's how much it took me to use up all of my 5 moles of copper chloride, that's going to be the amount used up by my limiting reactant. So minus 3.33 moles of Fe, and we're going to get our final answer. Whatever 7.5 minus, okay, so we can bring up our calculator here. So 7.5 minus 3.3, okay, 4.2. Okay, so we're going to go ahead and 4.2 moles of Fe is going to be excess, or leftover. Alright, so this is just a quick review of limiting reactant, and I hope that this was helpful.